Sweet.
Okay, sorry about that to anyone that maybe was watching our other stream or IDK. But we were trying to stream to Twitch at the same time and it was not working great. So we'll have to keep messing around with that one. But we are live now on YouTube and we are good to go. If you
I can't find.
Jaden, don't tell us we're not.
I can't find it.
Jaden, we're live.
Oh, I found it. Hello. I found it.
That's good. I think we are, right? We should be.
Yep.
Because mine tells me we got 0 viewers. Oh yeah, we got 2 watching. Okay, we're good. Hello, and welcome. All right, Jaden.
Yes, Kip.
Let's start off by reminding people what tonight is all about. So, for all you...
what is tonight all about?
Tonight is all about free live tutoring.
Did you say free?
Dude, 100% free.
Dude, but what if the quality is just so bad that I don't learn anything?
Dude, but the quality is so good, you will learn something.
And why is it so good, Kip? Because you and I, that's right.
We're smart.
Our brains, we can help people with them, I think.
I think so too. And we're smarter than your teachers. Do we dare say that?
Sure.
Sure. But yeah, so if you are watching and you have any questions, throw them at us. If not, we'll sit here and do other weird, bizarre things. Or maybe Jaden wants to talk about something. I don't know. Or if you know anyone that has questions, please tell them to get on and ask away.
So we get a question from Reddit. It says, prove that if x is a positive real number, then x divided by x plus 1 is less than x plus 1 divided by x plus 2.
I think that was a notification from Reddit, but sure, we can go ahead and do that.
And I think there's another problem too. Having trouble with changes in interval.
Yeah, see, these are just comments on the Reddit page, so we could just do it.
Dude, should we prove that if x is a positive real number?
Yeah.
Cool.
Here, I'll make a little sticky note. Do.
Let's see, you gotta. It's gonna be exciting.
X is a... Oops, I'm getting my mathematicals unsolved popping up because of my hotkeys. Jen, you should type it out.
Are you on the Jamboard?
Yeah, dude. I'm typing up a sticky note.
Oh, it just barely popped up.
That's because I was typing it. You go fix it.
Okay.
You type it out.
Okay. Okay, I have an idea. Maybe I'll just... There we go. Copy. Paste. There we go.
Oh yeah, there you go. Nice.
I'm gonna just enter right wide. I guess I just have to do it with spaces. There we go. Oh, it didn't change it. Never mind. I tried to get all that equation onto like one line, you know,
Here, if we
but
make it,
I guess the stick.
Yeah, that's weird. Okay. All right. Jen, prove it. Go for
it. So in this situation, right, you might at the beginning just choose a couple numbers that are positive, real numbers. All right, just to double check yourself. So if we chose like 1, you could get 1 over 2, is less than 2 over 3. Is that true, Kip?
What? I spaced out. But yeah, that's true.
Yes, it's true. So, yeah. So you might just check a few cases, right?
Right.
Check 1, check 2. You see this going on. Then we would have to say you basically show, like, you make an assumption.
You can't make an assumption.
You can.
Assuming's
Because
bad.
then no, it's good. It's perfectly fine. You assume that n, if you plug in n in there, it works. But then you have to show that because n works, you have to show n plus 1 also works.
Okay.
So you assume n being a positive real number, but then you plug in n plus 1 also, and then you make it work out.
Okay, show me.
Okay, let's do this. So you might have like a base case. Let's say x equals 1.
Okay.
Okay. Then we show it, that would be 1 over 2 is less than, and I'm just doing the easy math in my head. Okay, just
Okay.
2 over 3. And that checks out. Woo! And then maybe someone would check, I don't know, let's check x equals 2. Does that work? We get 2 over 3 is less than 3 over 4. Woohoo! That checks out. Now I assume, okay, assume x equals n. Checks out. So let's just write this out. N over n plus 1 is less than n plus 1 over n plus 2. Woohoo! I assume that. Now I have to show x equals n plus 1 works, right? Because that's going to be the next integer, right? And if I show this, then I've proven it for all integers, right? All positive real numbers, really.
Okay. Do we, after we prove that, are we going to have to show if it's less than 0, it doesn't work?
In this situation, we could extend it and just show that it doesn't work. And in that situation, all we'd have to do is show just one case.
Right.
-1. But, okay, so now we're like, holy moly. So this is going to be an n plus 1, right?
Right.
Over n plus 1 plus 1 is less than n plus 1 plus 1 over n plus 1 plus 2. So how do we show that, Kip?
I don't know.
How can we use that assumption part to show that this is going to be true?
I don't know, Jaden. How? I'm trying to follow you here, but this one's
so if we do a little bit of math, right? I'll grab the laser. This part will be this part, right?
Oh, dude, your laser is green.
Is it really? It's red on my screen.
Oh, really? It's green on mine. Is mine blue?
Check it out. It didn't show up. Oh, now it is. That looks green also.
Dang.
Okay. Yeah, so this is going to be this one.
Okay. Oh, I see that.
Right?
Okay.
You follow that?
Yeah, I'm following that.
Okay, and now we say, let's see. So because we have this, all of this, right? We have that. Now we get n plus 1 over n plus 2 is going to be less than, and then we could do some math here too.
You get n plus 2.
So, wait, actually, a better idea in this situation is to figure out, right, something is always going to be, I guess, less than or equal to itself, right?
Right.
So if we can figure out, can we pull out anything over here to make it look like this? N plus 2, and then if we have some other part plus something, right? Some question mark. Can we do that algebraically, Kip, just off the top of your mind? Let's see if we can.
Not prettily.
Yeah, we might have to manipulate it a little bit. Oh, yeah, we can. So if we just do adding, right, with fractions, if we have the same denominator,
right,
it will be, you just add the numerators, right?
Right.
So really this would equal, this would equal a 1 over,
Yeah, see?
because we'd still have this plus 1 over here.
Yeah, but you could still...
N plus.
Yeah. I don't know, Jane. I'm getting. I think we're getting ourselves a little confused here.
Well, the idea is there, right? If we can algebraically manipulate this so it would be like less than or equal to itself, but then we'd still have a plus another fraction, so then it would be greater. Does that make sense in your mind? If you have
Okay, yeah, I understand.
Equal to each other plus some other piece, it's going to be larger.
Right.
Does that make sense?
Yeah.
Trying to think on.
I don't know. I'm. Yeah.
Yeah. Let's see.
Okay, we got.
Okay, so there's another way to do this. It's a proof by contrapositive.
Okay.
So this proof method that I just did was a proof by induction, mathematical induction, which means you have like the base case, you make your assumption, and then you prove plus 1, right?
Okay.
A proof by contrapositive is you first suppose that it's not true.
Okay.
Right? So you're like, okay, so this x over x plus 1 is less than x plus 1 over x plus 2 is not true. Okay. So then you would assume the opposite, right? So then we would assume x over x plus 1 is greater than or equal to the x plus 1 over x plus 2.
Right.
Then we do a little bit of algebra. We subtract the x over x plus 1 on both sides. Okay, so we'd have 0 is greater than or equal to 1 over, doing some algebra, you'd have 0 is greater than or equal to 1 over x plus 2 times x plus 1. And remember how we assumed this was not true?
Yeah.
Or that this would have been true? We now prove that, oh wait, that doesn't make sense, that 0 is greater than some integer that's larger than 0. Because you'd have 1 over a positive number.
Okay.
So that means it wouldn't be true. So that means our assumption was wrong, making the opposite true, which is what the original thing was.
Okay.
Okay, should we write that down now?
Yeah, sure.
Okay. I'm going to go to the other side, or next slide.
Okay.
So we had x over x plus 1 is less than x plus 1 over x plus 2, right? So we say, suppose this is not true, so not true. Assume the opposite. So we assume, that says assume, if you can read that. We assume x over x plus 1 is greater than or equal to x plus 1 over x plus 2. So now we subtract all of this fraction on this side. We do it on both sides. Okay, so we're doing this.
Okay.
And we get 0 is greater than or equal to. We gotta get common denominator, right? So we need, let's see, how do we get this to be a common denominator? Multiply this.
We gotta multiply both by, you gotta multiply this by x plus 1, right? And then that one by x plus 2.
Yeah.
So we get, here, I'll do the left one and you do the right one.
Okay.
So I get x squared plus 2x. Hey.
So where yours end? X squared plus 2x. And it's going to be minus all of this. Boop, boop. Okay, so those cross out, those cross out. Boom. We're left with 1 over
x plus 1, x plus 2.
Yeah.
Hey.
Okay, so, and then at the beginning, remember how we said x is a positive number?
Yeah.
Meaning, no matter what happens, this fraction is always going to be greater than 1.
Okay.
Right, it's 1 over some positive number. That means it's greater than 1. So this is not true, right? Our assumption was not true. Meaning, therefore, or thus, this is true.
Okay.
That was approved by Contrapositive.
Dude, that sounds a lot like our fact checking, you know?
Yeah, it did.
Anyone that hasn't seen it, you should go watch our fact checking video will probably like show up right here or something, or right over there. I don't know, somewhere, you know, and you can go watch it.
Yeah.
Yeah.
Are
Okay.
there any questions in the chat?
Yeah, you guys have been awfully silent tonight.
That was a fun little math.
Oh, Jaden, by the way, just so everyone
Yeah.
out there knows how TikTok famous we are at 998.6 thousand views on our video. We are less
Wow.
than 2,000 views away from 1 million views. So, we're TikTok famous for all you people out there.
That's actually really crazy.
Yeah.
Did you end the Twitch stream?
Yeah, I did.
Okay.
Yeah.
I just looked at it. I was like, oh, it's not working.
Yeah. No, I ended it
Well,
because we'll get the Twitch thing set up hopefully by next week, working better. But
yeah. Whew. What a cool little proof that there was.
I'm still a little confused about it, Jane, but I think I got it. But I did realize something about it. Here, I went to the next frame.
Yeah.
Next slide. Because we had x plus 1, right? Over x, or we had x over x plus 1
Yeah.
is less than x plus 1 over x plus 2. And on that right-hand side, it's already essentially what you were saying, that n plus 1, right?
Yeah.
On the right-hand side, because you could get, you know, on the right-hand side, you could say x plus n, or, you know, 1 or whatever. And then you could do x plus 1 plus 1. And then I don't know where you go from there, but I feel like that's important.
Yeah.
I think that's where you're saying then you have to prove that you could break it apart, right? Is that what you're saying?
Yeah, I was thinking somehow like factor something out of it or something to get this on the left-hand side plus something else. That's what I was thinking, but off the top of my mind, this
Partial fraction like decomposition?
Yeah. it might be something like that, where the other proof was just as elegant, but a lot easier.
But I'm finally understanding now.
Yeah. When's the last time you've done partial fraction decomposition?
Not too long ago, actually, but...
Oh, really?
Because we could say... I mean, let's think about this here. Because we want to get it to x over x plus 1 plus something, right?
Yeah.
I mean, I think, Jaden, as long as you leave it even like this, you could leave it like this. Or I guess this is, no, wait. Oh, I get what you're saying. Okay. Yeah, I don't know. That's tricky. Because we can't have that x plus 1 just... I don't know. By the way, that one will say it's solved.
Yes.
Did you say there was another one on there that you wanted to look at?
I looked at it and it was just like some words having trouble with changes in intervals, word problems. So yeah, there wasn't really.
Okay. That's a bummer.
Yeah.
I mean, I'm sure I could find another one on here pretty easily if we go through. Because this is an entire Reddit page just on asking math questions.
Does anyone have question that is watching? Just write it in the
Anything.
chat.
Anything at all.
Anything. For example, do coconuts exist? And we would say, I don't know. Ask my brother. He lives in Hawaii.
Yeah. Jaden, I can't find anything worth going for.
Oh, we got a question. Der x to the 3x, which I'm guessing that's derivative of x to the 3x.
Yeah.
Let's do it.
Let's do it. Okay. So we got... Jen, how do you write derivatives, like the notation? I always get screwed up on that part. Like, how do you say that you want to take a derivative?
You do d over dx. And then you put it in parentheses.
Cool.
So that would be x to the 3x.
Is it x to the 3x or is it x to... Please clarify, is it x to the 3x or is it x to the third x?
Oh,
you
yeah.
guys can please clarify that. That'd be useful for us. And Kelsey, yes, you can eat some ice cream. We're not getting clarification in yet. Well, we could do this one and then do another one.
This one's gonna be log.
X to the
right?
3x. So it is x to the 3x.
Yeah.
Do we want
a log, isn't it?
Yay, Kelsey, it's solved. I don't know. Isn't it a chain rule kind of deal?
Yeah. It's like using chain rule, but I'm pretty sure when you have an x to an x. Let me.
No, it's x to the negative that you get a log, isn't it?
I'll check.
Or to the negative first gives you ln. I don't know. It's been a long time since I've done an x to the x. I'm guessing it might be intensive. So no worries if you don't have the time. Oh, we got plenty of time. We got nothing but time to solve this intensive limit. Or this intensive derivative, whatever it is.
Let's see. Integral or differentiation tables. So
Jane, I'm cheating right now and I'm looking up the answer.
are you just doing Wolfram?
Yeah.
So
But they can't see it, so they don't know.
right. A constant to a variable is the constant and then ln of the
Okay,
constant.
so you ready for the, yeah, here's the
log.
whole thing. Okay, well, I'll tell you what the answer is, and then we can try to figure out how you get to it. Ready? The answer is 3x to the 3x, and then, so that's the exponent 3x, and then we go ahead, and then
Am I
in
writing this
parentheses we have,
down?
no,
Oh,
I mean, you can if you want. Log x plus 1.
log x plus 1.
Yep, just like that.
Dude,
That's what we got to get to.
Should we try it with the definition of the derivative?
Yeah. Should I see, you know, Wolfram gives you that little start if you don't pay. Should we see what the
Step by step.
step 1? Okay. Take the natural logarithm of both sides. Oh, yeah, that makes sense.
Oh. Okay.
So maybe does that make sense? So
Yeah.
we've got it. Yeah, so
I
we've
have to
got,
set it up too.
okay. So we got log of y of x
And then
equals log of 3
it's just x.
x. Oh yeah, whoops, I was writing the
3x
answer.
log,
Boop.
right?
Yeah. X, what? That's what it says to do.
And
then
then
we
we
can,
move that out front, right?
yeah. So
Okay.
we can say log of y of x equals 3x, and then log of x, just like that. Okay, so now we're going to have to take the derivative of both sides, though.
Yeah,
right?
so this is a power rule. Right? So we
Yeah,
get the derivative of the first times the second plus the derivative of the second times the first. Right?
right. Okay. So you do, so we get 3 times derivative
Log
of the first,
x.
right? Yeah, log of x. And then we
Plus,
add derivative of the second. What's the derivative of log of x?
it's so assuming what would our base be in this situation? Is it 10?
I don't know as if it matters. Will it matter? Because I'm guessing we're going to do the inverse of a log at some point. Right?
Yeah.
Sure, let's make it 10. Why not?
Log x. Okay, so it would just be 1 over x.
I thought that was the in. Okay. So, yeah, we get 1 over x. Okay. Times 3x, right?
Yeah.
Okay, but we're not done yet.
No. We have to, don't we have to do something to this side?
Yeah, we have to take the derivative of that side.
So that would just be
1 over y of x, right?
y, yeah. And our y-x
So,
is this function, right?
yeah. So we get 1 over y of x, which equals 1 over x to the 3x. And we're going to say that's equal to 3 log of x plus 1 over x times 3x. I guess we could
Just
cancel out one of
simplify
these
that to be
x's.
3, right?
Yeah.
Yeah, and that just equals 3.
So,
Okay. We're getting somewhere.
dude, we're getting there. We're almost done now.
True.
So, dude, you want to take over now? Your turn. Jane, we're almost there. You got this.
Yeah, I'm just thinking, do we... if we multiply this x to 3x to this side, right?
Yeah.
We just get
Right.
1 equals all of this.
Yeah, I see what you're saying.
So shouldn't this
We're
be
missing.
the implicit differentiation or something like that? Is that what so you still have your derivative on this side? Yeah, because this would be, we take the derivative with respect to x.
Right.
So we'd be left with a y prime on this side.
Yeah, I think you're right. Because it's like a weird chain rule kind of thing, I think, is what you're saying.
Yeah.
Yeah.
I'm not sure
I
if
think
that's
you're right.
exactly how it would be. If it's in the numerator, that would be very convenient.
I think you're right, though.
Yeah. Okay. So then we would just multiply this x to the 3x on both sides. We get is equal, so y prime equals 3 x to the 3x log x plus 3x to the 3x.
And then you can just go ahead.
Then you just factor out the 3x to the 3x, and we get what's there.
Yay! So this is solved. Even though we made some little cheater thing, I don't think it's cheating. It's just a notation issue that I'm not sure about.
Not. Oh, whoops, that should just be one. Factored out the 3x to the 3x. Cool.
Cool. As far as where that y prime comes from, I mean, we did it right, obviously, because we got to the right answer, but where that y prime came from, I'm not so sure. But it's there. Thank you for that fun question. It was totally mathematical. So.
Agreed.
Cool, cool, cool. Any other questions out there tonight? If not, I mean, we can always end early tonight, but.
Yeah.
Because no one wants our help.
I'm guessing it might be intensive. Oh, You already read that. Very nice. That's what we got.
We did it. I mean, we kind of cheated a little bit at the start there just to get us going, but
Yeah, we kind of looked it up. But,
yeah,
take the log of both sides and you're on your way.
on your way. Cool. Well, Jaden, what do you want to do? Do you want to keep going or do you want to be done?
Do you have any other questions?
I don't have any questions. Do you have any questions?
No, I don't think so.
Okay, well, we can end 15 minutes early tonight. But thanks all for watching. Don't forget on Tuesday at 8 p.m. what will be happening. We will be going over more about the kinematic equations and actually using them to solve real world problems. And we will also be talking about derivatives and how they can be used to find minimums and maximums of functions. And so it will be very, very cool stuff.
Of certain things.
Yeah, because we'll first solve for minimums and maximums using just standard algebra, and we'll show how big of a pain that is. And then we'll go ahead and do it with calculus and show how much easier it is. So if you guys are wondering, you know, all these things that we've taught you in the past 3 weeks, what you can use them for, we'll show you. And it's pretty cool stuff. We'll be talking about projectiles, like launching things through the air and being able to calculate that. Like, how high is it going to go? Because, Jaden, that's a maximum.
What?
Yeah. Did you? So stay tuned. Next Tuesday at 8 p.m. Mountain Standard Time.
Yeah, be there. I'll be there.
Thanks.
Will you be there?